Okay, we will find dy dx and also d2y dx2 for this perimetry equations right here. Here we go. For dy dx, of course, we know this right here is equal to dy dt over dx dt. And now let's just do our derivatives. For dy dx, for dy dt, okay, sorry. For dy dt, just look at this and differentiate that. Of course, we just get 1 over t from this part. So that's it. And then, for the bottom here, for the dx dt, differentiating this, remember the derivative of inverse tangent, what we have to do is 1 over 1 plus parentheses square, and we will have to enter the inside right here into this parentheses. So we have the square root t minus 1. And then, don't forget the chain rule, multiplied by the derivative of the inside. Derivative of square root is just going to be 1 over 2 square roots. Don't forget the little 2. 1 over 2 square root of t minus 1. And then, don't forget the chain rule again. But in this case, the derivative of t minus 1 is just a 1. So if you forget about the last chain rule, it's okay because multiply by 1 it doesn't matter. Okay, let's see what we can do. Perhaps look at this part. Square root cancel, that's good. And then we get 1 plus t. This is plus t and then minus 1. And of course, this and that will cancel. So just have t like right here. And then let's see. Let me just perhaps write it down slightly better for you guys. On the top is 1 over t. On the bottom here, all in all, we get 1 on the top over 2t. And then square root t minus 1. Yep. Yeah. And what we can do is, of course, bring this up. And perhaps the easier way to do this is just multiply the top and bottom by 2t square root of t minus 1. So let me just show you guys the word so we can see a nice cancellation. This whole thing and that will cancel. The 1 doesn't matter. And this t and that t will cancel. So all in all, for dy dx, we just get 2 square root of t minus 1. So that's it for the first derivative in the sense of dy dx. Now, moving on to d2y dx2. Well, remember this right here, we have to differentiate with respect to time of our first derivative. Let me just write down dy dx right here. And then divided by dx dt. Okay, so here we go. We are going to put down d dt of the dy dx is that. So that's 2 square root of t minus 1. And then divide this by dx dt. Well, I'm just going to enter the answer right here. We have the 1 on the top over, again, 2t and square root, right? So it's 2t square root t minus 1. This is our dx dt. Now to get the derivative right here, so perhaps I'll do it on the side to make sure we can see this carefully. d dt of 2 square root of t minus 1. Alright, here we go. 2 is 2. And then multiply by the derivative right here. This is just a constant multiple, so that's why you maintain the 2. Derivative of square root is going to be 1 over 2 square root of the inside t minus 1. And check the chain rule. Derivative of the inside, well, it's just 1, so it doesn't matter. This and that cancel. Therefore, we just get 1 over square root of t minus 1, yeah? That will go on the top right here. So, this right here will give us 1 over square root of t minus 1. And then divide this by this, which is 1 over 2t square root of t minus 1. And we can simplify this. You can just multiply the bottom and the top by 2t square root of t minus 1. 2t square root of t minus 1. This and that will cancel out entirely. This and that will also cancel out. And the truth is, in the end, man, the answer to this is rather surprising, huh? Because for the second derivative, right, in the sense of d2y dx2, we actually just end up with a very nice number, well, a very nice expression, 2 and also the t. Just like this. Very, very interesting, but that's just how it is. Anyway, yeah, go ahead and practice this again, right? Because this right here, it's perhaps slightly more complicated than the other ones we have done. Anyway, that's it.